We're going to go ahead and get started, folks. Thank you for joining us. We're a few minutes behind, so the instructions are to let us go into the next break a little bit. I'll let you decide when we get to the Q&A how long we stay, so you can just keep asking questions or not. I want to introduce to you Nick Flores. He's a senior data scientist with GE Aerospace, over 15 years with GE, including 11 with aerospace. He transitioned from the field of mechanical design engineering to data science. As a data scientist at GE Aerospace, he has leveraged a deep domain experience to unlock data-driven insights for supply chain, machine health, and engine forecasting initiatives. That's a lot of work. Recently, he led an initiative to develop a customized large language model, LLM, with internal company documents. I think LLM in the topic, as somebody mentioned previously, if you put LLM in a topic, everybody packs the room, right? So I can see all of our OBAIS faculty are in the room. And just want to welcome you. My name is Jeff Schaefer. I'm a professor here. I do data visualization and some other courses, and have been studying LLMs the last year, so I specifically asked to chair this one just so I could hear this talk. So without further ado, here you go. Thank you.
Thank you guys, and thanks for having me. So I'm going to talk about large language models and their challenges and opportunities in business use. And I work for GE Aerospace. I will give a quick plug for GE Aerospace. In case you aren't familiar with what we do, we make jet engines and lots of other avionics and cool stuff that go on airplanes. So, but this is our purpose. We admit future flight, we lift people up, and we bring them home safely. Some cool stats about our business: every 2 seconds an aircraft with GE engine technology takes off. So it just shows you, it's already a complex technology, and the fact that we have, we make so many of these things. And really what this data doesn't say, because this is like from our company pitches, right, is being a data scientist at GE Aerospace is incredibly exciting, because on a lot of our coolest, most high-tech technologies, we're very vertically integrated. And so it gives you a good data, there's a good data-rich environment with which you can start to look at some of this data and draw insights from it. So, and then on the military side too, you can just see how big our fleet is for the U.S. military and other allied militaries around the world. So. But today I wanted to talk about large language models. So I guess there's an agenda I put together here, but really what I want to give to you guys today is our journey. The good, the bad, and the ugly that comes along with it. Because I believe that when you get to see the full picture, the lessons will really start to hit home. And one thing about GE Aerospace, as I mentioned, we work on a lot of technically challenging products. There's a lot of lessons learned that you kind of start documenting, right, when things don't go the right way. Because that's an interesting thing about lessons learned, right? Whoever says, hey, make sure you start writing documents and lessons learned when things go really well, right? You kind of forget, sometimes to do that. So another way to say that is that failure can be our best teacher. So we've had a few failures. I won't really call them failures because I'm the one who's done this stuff, right? So, but we've had some things, definitely I could say they're lessons learned. I want to share those with you because I think we can all get a lot from that. First, I wanted to kind of show you, how our team got started. But first, let's talk the time frame here, right? Because I think this is pretty incredible. GPT-3 was released in June 2020, and there was a bit of what you might call a lull. But right, of course, there's some other key releases that came out: GitHub Copilot in October 2021. But of course, we can all go back to December of last year when ChatGPT came out, right? Maybe a quick show of hands. How many of you have used ChatGPT in the room? Okay, that's everyone. All right. And one follow-up question to that. How many of you have tried playing with large language models, like from a code-based perspective? Maybe like a few people done some fine-tuning maybe, or just use them for inference. Okay, good. So this is a pivotal moment, right? And so, things have been developing very rapidly. And as a business or an organization or a data science team, like how do we react to these any of these developments that are on the timeline here, right? So on one end of the spectrum, you could be really ahead of the game and say, well, GPT-3 was just released back in June of 2020. So July of 2020, you can say, let's get a working team to be, pull together and let's start studying this technology, right? I don't think any of us probably did that, but that's one end of the spectrum. The other end of the spectrum is, maybe the CEO, hey, to an executive, what are we doing about this ChatGPT thing? How should we be looking at this technology? Maybe the executive gives a blank stare and then runs off and goes, tells someone like me to kind of say, hey, go pull something together on large language models, right, and generative AI. And I actually don't think this is necessarily a bad scenario on the right? Because what has ChatGPT, what's been the development, right? I think it's been scratching an itch that we didn't know we even had, right? It's something that came along and it's been solving problems for us. It's been helping us out in ways that, now a lot of us say, well, we kind of need it to do our daily job or to be even more efficient at our daily job, right? So, but a lot of the times what you have people happening is there's a lot of people now, like when you're in that mode of, okay, here's what should we be doing about this? There's a lot of use cases that kind of come out and you kind of have to say, well, what should we really be doing with it? You have to ask those tough questions because it's not like it's an incremental technology that has, that people saw coming, right? So, and then this is where we kicked off our generative AI. So this is another point of reference. So I'm coming to you guys today, and I can say if ChatGPT hadn't been released in December of last year or released, then I probably wouldn't be standing here. I know I wouldn't be standing here in front of you guys. So, it's offered opportunities for us as data scientists to grow and work with this technology. So what I wanted to do, when our team got started and kicked off back in May, one of the first things I did was put together a single slide. I wanted the slide to say what our goal was, what true norths we were going to use to guide us, and then how we would achieve that goal. And this is that exact slide. I haven't changed anything. So this is one of the first things I did, but it was also one of my first mistakes. So if you guys bear with me a bit, I'm going to kind of mark this up. So one of the first things was, develop a working proof of concept for homegrown LLM that can perform text generation or chat-like capability with aerospace-specific prompts. But in order to do what? Right? The use case here, exactly how we're going to use it. Okay, we can generate text, we can chat, but what is it actually going to do for our business? So this is something that we kicked off. We didn't exactly know how we were going to use this. So that's an important thing to keep in mind. And then the other thing, well, why exactly do we need chat-like capability? I don't. Is that a given that we need to be able to chat with it? What's the importance of needing to kind of have this long-winded conversation back and forth? The other thing, infuse aerospace data for fine-tuning. I think that was something that we definitely thought we wanted to do, but once again, there's still some questions about how we would use that and how that would be accomplished. One thing I did put on here is keep our IP or data private. That was definitely something that at the onset we said we don't want to just dump our company data into ChatGPT, right? This is before they had announced that they were, at this point they're starting to open like the commercial licenses for ChatGPT where they don't keep your data, they don't use it to retrain their models, but we definitely, either way, we want to make sure we keep our IP and data private. And then I put this initial high-level step plan together, and it sounded pretty good at the time. But more to come on that. And, what does private mean again? Because I think that can mean a lot of different things, right? If you talk to different people in your business, maybe that means data doesn't leave your firewall at all. Or maybe it means that it's encrypted when it's, in the hands of Microsoft or OpenAI. And so there's a lot of, I think I put that there just because, that you can say that, but even that is, you really need to get more specific about what you really want, what the requirements really are. Because that will drive what systems you have to use. So I think that's important. We had just a conversation before this about, maybe there's a lot of, deals being signed with Microsoft to use, their kind of generative AI capabilities with OpenAI. And they'll promise that they won't use your data, right? But would you really put your company crown jewels into that software? I think that's a tough question for people to say yes to still. So we dove right in. So now we're like in June of this year, and we're diving right in. My thing was, okay, let's pick a model first. Here's a tree that some of you may be familiar with this, but because it's been published, but it's kind of a tree that over time, here's some of the open source models, the closed source models. So we took a look at these. We used things like Hugging Face leaderboards, right, to find what are the best LLMs and performing for different tasks right now. And we'll also have to consider how has the model been fine-tuned. And so we gathered some of the top open source LLMs, and we kind of racked and stacked them. We looked at different versions of them, and we kind of down selected to a few that we're going to start with this. The next thing I think it's important to do is to secure a compute and build environment to run these things, because it's one of the first hurdles that you will run into if you're not using cloud services, right? Cloud services is great because you can spin up high compute environments, but of course it's costly. For us, we wanted to get started. We wanted to prototype code, so I think it was important to. This is actually my personal workstation on the left there, the Dell 5820 that's got an NVIDIA RTX A4000, which is a 16 gigabyte GPU. But one of the first things you appreciate when you work with these is how much GPU RAM you need. We also were fortunate to have this NVIDIA DGX station, which has 4 NVIDIA Tesla 32 gigabyte GPUs. But it's, as I will show in a bit, it's important to build a plan for more compute early on, and also to consider a cloud service as part of that plan. And then, so I started collecting and cleaning data, and I think this is something that if you're building one of these applications, what data is meaningful for you to collect? And then you also have to think about how will the model be used, once again, that use case. And then taking time to scrutinize the quality of the data that you scrape. This will be a lesson learned that I'll talk about too. And so some of the early results that we had. So our idea here was kind of this model, this workflow that you see on the top right. It's this, what I'm calling a domain adapted model, and where you essentially take the data that you scraped, our own company data, and you have a pre-trained model, and you actually do you do a little bit of continued pre-training, so it kind of understands some of the lingo, some of the acronyms that are specific to your business, and then you can do some supervised fine-tuning from there, and then a user can ask a query and get an inference. So this was, get an answer to their question. So we started with GPT-2, really just more from a prototyping, can we get the code running and build the right environment perspective. And then also Falcon 7B, because it was the next smallest one that we had. We started, I did this continued pre-training step. And we actually succeeded pretty quickly in creating a model that could, spit out highly specific GE jargon. And a lot of it somewhat made sense. It talked about turbine blades having distress in certain locations. And, thankfully coming from an engineering background, I was able to kind of say, well, that sounds pretty good, but if you put that in front of a chief engineer, he would be like, this is some BS right here. It's good BS, but it's still BS. What was the, I would say at that point, it would have been good to take a step back and say, what's the use case again, right? How are we going to use this? Are we going to use this to, tell us how to design new parts, right? Is that what the purpose is? Because the model does have potential for hallucination, and that's what you get with any of these, LLMs that are just kind of like run on inference at this stage without any kind of guardrails around them. So, I could have taken a step back. No, instead I'm like, okay, let me move on to Falcon 40 billion parameter model, and let me get into this NVIDIA workstation that we have here, because I wanted to use those GPUs, right? So I did the continued pre-training step again with Falcon 40 billion. And this was a bit of a lesson learned for me, because if you're familiar with working with NVIDIA, there's a command NVIDIA SMI, right, that kind of gives you this command window here. You can kind of see, okay, well, we had 4 GPUs, and you can see all the temperatures there in degrees Celsius. Well, what I found was I said, well, one of these, the bottom GPU, all of a sudden it's reading 92 degrees C, and then all of a sudden it went offline. So I had to figure out, okay, first off, now I can't train at all. So I had to find the command to turn off, or basically to make one of your GPUs invisible. Okay, I've got 3. Let's keep going, right? It's only a $15,000 GPU, no big deal. Well, actually, another one hit above 90 degrees, and I said, okay, well, 50%. I still have decent chances there, right? Let me keep going with this. I need to get some results. Meanwhile, maybe I should have been thinking about the cloud or something else, or maybe fire hazards. I don't know, but 92C is pretty high. And then the third one went out, and then I turned it off. So I said, okay, my boss Ryan, I said, hey, can we take a look at this? There's something going on here, and but essentially, I was down $45,000 worth of GPUs at that point, and I needed to start looking. I guess when I said I needed to take a step back, this was a step back for me. And so I kind of took that time to say, what do we really need to do differently here? Because if I'm honest with myself, it wasn't giving me the kind of answers that I wanted, and I didn't even know what use case I really needed for this point, right? So I want to take it aside here because I mentioned the use case a lot now, but I think where we are right now with large language models and their application is we are in a bit of a wilderness. You're in a bit of a wilderness that you kind of have to bushwhack, you have to cut your way through down to what do you really want to do with these models. I put a few use cases that have come out, but I think if you work at a business, there's someone who pops up and said, hey, I used ChatGPT yesterday. Let's have a model that does, that I can just ask some questions to. And it's important to say, well, why do you want to ask questions? Well, I just want to ask some questions to it, like about our own stuff. I don't know, right? They don't really necessarily know what they want to do. So I think it's important to be almost, ruthless, right? Like, kind of like, nicely ruthless, right? When you kind of work with some of these use cases that come up. We have a few engine manual question and answer, and we've got kind of like your car engine manuals, right? How to replace different parts, what parts have certain limits that you need to replace them at. And we have one application that's question and answering over engine manuals. If I'm really ruthless, I could say, well, why don't these guys, why do they need this? Can't they do, a control F and find where they want, or maybe they should know this information already. But maybe there's use cases where, how about across different, like if I want to compare different engine manual limits, they could across different PDFs, then that might be an application there. Another one, similarity search and suggestion. Right, we write a lot of, as engineers, in our company, we write a lot of documents that say, okay, well this part, maybe it didn't quite meet the drawing print, but I can accept it because I did these engineering analysis, right? And then we document that and store it, and perhaps the next time one of those cases comes up, you can kind of do a retrieval where you pull back and via similarity search some of those similar cases, and then you can use it to help you write that. But then I could also look at that and say, well, I mean, these have to go to the FAA, right, to get signed off, or the FAA's representative who works for GE Aerospace. So, do you really want, is there going to be a human in the loop, right? That kind of makes me feel a little bit iffy when you start to do that as well. But perhaps similarity search and suggestion to help you with that maybe is okay. CSV question answering. So this one's an interesting one. So we had an executive come to us, and he was clearly frustrated. He had been in a meeting with one of the vice presidents of the company. And he was, he basically said, yeah, the vice president, he asked us kind of random questions, what suppliers do we need to be kind of negotiating more with, or which parts are costing too much, and we don't have the data in front of us. And I just wish that I could ask a question and get a response, real time. I could just he could ask me a question, I could punch it in, and I could feel his frustration. But I'm, as a data scientist, I also realized, well, even if we, could maybe do some quick SQL queries, right? Generate some SQL queries. Are you going to trust that responding to him in real time? How? Because then you start to think about what does it mean to have real time inference like that, and you start to think about, well, do I really want my large language model generating arbitrary SQL queries? Hopefully they're right, but there's a risk for kind of prompt injection there, where you could if you get the model to say the wrong thing, automatically run it and generate some results that maybe you actually don't want that code running at all. So that one's an interesting one that I think maybe what he is speaking to is a larger problem that maybe you kind of say, let's take a step back. Maybe the data, maybe it's hard for you to get access to the data that you need, or you don't know how to access or how to get that data. So sometimes, working on these kinds of things, you have to kind of pare back and really understand what's the root cause here. contract question answering. I'm going to talk about this one, but we have essentially a team that models our contracts, and it's difficult for them to do their analysis because each of these contracts is like kind of a one-off, right? With all these different airlines where, you know, the prices are different, the structure of the contract, the payment terms are different, and they're trying to kind of make sense of these, figure out which ones, you know, we need to renegotiate, those kinds of things, which ones are risky for us. So that one I think is a good candidate that I'll come back to. And then code generation. I think in all of our businesses that where we write code, you know, if you're not using ChatGPT for generic code, then you probably would love to be able to, you know, have your own code tool where you post your own code in and say, hey, optimize this for me, or tell me how I can do this better, right? So, but I think you have to, if you're working in this space right now, because we're just in, you know, this kind of green new area, you have to ask tough questions of your use cases to avoid wasting time on low yield efforts. So, not afraid to pivot. So this is where we kind of took a step back and we said, maybe we need to look at the RAG workflow, and I don't like that acronym, it's, but Retrieval Augmented Generation. That's really what it is. And so the issue is, as I mentioned earlier, the continued pre-training results, you know, illustrated that we were going to be susceptible to hallucination. And as most of you know, if you've used ChatGPT, there's still risks with ChatGPT doing that as well. So we decided that the risk of that outweighed the benefits of having a more generic, a more general model that can just answer business questions for us. I think it's important to note that there are some companies that have gone and trained their own model, like Bloomberg GPT, if you guys have heard about that. They've actually trained their own model from scratch. And they say it does pretty well. Of course, you know, once you work at Bloomberg, then I would ask you, but there's always going to be some risk of hallucination with these. That I think there's a, you know, you have to really consider that heavily. So our team decided to pivot towards a retrieval augmented generation workflow, and I'm going to talk more about that. But it does require an embedding model, and which introduces its own source of variability into the results. And it does. The drawback to this also is it does place greater emphasis on data preparation. So I'll go more into this in a bit, but I want to take another aside here and talk a little bit about architecture, because I think it's important when you're working on these to have a good intuitive sense of how much, you know, you hear. I've thrown out like Llama or you know, Falcon 40 billion, you know, Llama 2 has 70 billion, GPT-2 XL has 1.5 billion. So it's a good, you know, I kind of put this chart together to say, okay, I've got my Dell 5820 there on the bottom. You know, that our single DGX station, assuming you know you haven't over 10 GPUs there, right, has that capability of 128 total. And then we actually have access to our Global Research Center's network of GPUs, of DGX stations, essentially that you know, we can scale up even further there. But you know, I put some of the models here. You can see how significant of a challenge, and just, you know, just getting code to run GPT-2 XL on your own local machine, you know, you're starting to hit in a 16 gigabyte graphics card is nothing, you know, it's not small. So, and even just 7 billion parameter model, you're out of that. Now, this is in the full floating point 32 inference memory. So the first thing you can do is on almost all of these, you can cut that in half right out the bat. You're not losing any accuracy. Cut that in half to floating point to half precision, or floating point 16. And you can see where you start to get. Now there's still some overhead for inferencing and everything, but that's right off the bat. Now this is just inference. Of course, if you're training, you also have to consider that, and there's other optimizations that you can use for training too. But there's also, you can go down to integer 8 for inference. So now you can start to see that, okay, some of these models like the Falcon 7 billion, now that's in play in your local machine. GPT Neo X, which is another open source model, is getting close, but you're definitely, so these kinds of things, you know, you start to say, well, okay, if I want to deploy this, now I kind of get a better sense for how many GPUs I need. You know, and you can see there's probably a slight performance degradation going to int 8, but it might not be noticeable for your applications. So, but you do have to consider, okay, well, if you're training, then there's other things that you know, there's optimizations that come out like parameter efficient fine tuning, PEFT, which you can use. And then of course, you have to consider how the end user is going to engage with the application. So this is key to architecture. If you are, working with a proof of concept for a single team that's maybe like 10 users, then you're kind of bounded, right, on how you need to deploy, what your costs are as you scale up. But say I'm trying to generate a general purpose, proprietary code generation tool for our business that's, I can expect 1,000 users. Well, now you start to think about, okay, well, gosh, where are my users located? They're in different time zones, so you're working differently. So how's that load balanced across the day, and then the month? Like, who's footing the bill for this? I don't know. But that's where you start to think about, how will your end user engage, and then how many end users will engage. So I wanted to talk a little bit more now about this contracts question answering. So I mentioned some key questions earlier when we were talking about use cases, but I'm going to be a bit more explicit here. Who is the end user? So whatever application you're thinking about, or someone has brought you, you got to think about who is the end user and what do they do. So for us, it's our contracts modeling team. And they create models for services business contracts. They provide insights. They assess basically for all these different complex sales contracts that the sales team signs. How are they going to impact our business? And throughout this exercise, you may start to learn a lot of things. Like for me, now I'm having an appreciation. Well, why can't we somehow give this information from this contracts modeling team as a feedback loop to the sales guys in the first place, right? Because they don't know, it's a downstream team from them that kind of says, okay, years sometimes after the sales contracts are signed, we start to evaluate them because this is a long cycle business. Maybe we should find a way to feed that back to the sales team up front somehow. But they assess essentially how our contracts are going to impact our business in all these different areas. Shop costs, profitability, labor costs, inventory requirements, where we're set up in the world, those kinds of things with shops. So, but then the next question I asked is, okay, well, what is the real root of this problem here? Why do they need something? Why do they need help here? What's going on? Well, in our case, the databases that they use for their modeling process don't have the single source of truth. So either it's not a good source of truth or it's just missing altogether. And the real reason is because the contracts themselves, or those PDF or those Word documents that get signed, that's where the true source of truth is. And when you've got 200 different airlines and someone comes to you and said, hey, give me our list of top 5 airlines that we need to go consider renegotiating with, how do you do that analysis? Do you open up 200 PDF files? Do you kind of rely on your database, which maybe is like, I don't know, 60% of the data, right? Like you can trust. How do you do an honest analysis with that? So that is okay. So I say, okay, the key inputs really are in this unstructured data. That actually makes me think that LLMs might be a right application here. But I still want to ask, do we even need LLMs for this problem? Right? So if I was to do this myself, how fast can I control F through a document to find the things that I need? Well, then they would probably tell me, well, it's said, they say it this way, in one contract, but it's said completely different in another contract. And it's you really can't control F your way through all of these contracts uniformly. And then, okay, well, maybe I could construct some good regular expressions, but really that's like, sometimes you need to extract paragraphs of information, right? It's like, or maybe it's a table of information that you need to pull out of these contracts. So, okay, well, what is the expected format of the solution? And so that is how is a deployed model needed? How many users we expected? I talked about this with the architecture stuff, but and then can standard prompts be developed? And I think this last question, does the end user even need an interface, right? I mean, ideally, yeah, it's kind of nice to have them be able to ask questions, but if they want a standard set of elements, maybe it's 30, maybe it's 200 elements from these contracts that are expressed in different ways, that they want them kind of extracted. What if I handed them a database and I said, I used an LLM to generate this, check some of these cases, please, but here's your database with you? Do they even need, because I think when you have a user using an LLM, you start to have to kind of face the the variance of that human element, right? How they express. Like I created a prototype, for example, and gave it to our data science organization leader, and he said, hey, I'm not getting the same results for you that I had to show him a screenshot, right, of what the results. I'm not getting the same. Well, okay, you misspelled this acronym here, and so I cried, and then he got the right answer. But that made me think, well, okay, there's some brittleness to this application as a whole that either I need to work out, or another way to solve it is, do they really even need to use it? Can I use it as a a turbocharged tool in my toolkit that can help them without them needing to actually interface with it themselves? Okay, so now let's talk a little bit about retrieval augmented generation and what that workflow looks like. So I kind of have here on the top left, so we kind of have a list of, I said about 200, it's probably about 500 contract PDFs. And the way retrieval augmented generation is, you have your documents, you have an embedding model, which is not the same thing as your large language model. So it's a smaller model that essentially, where you iterate over all of these documents, you take a chunk, it could be a paragraph, it could be a page, depending on the capabilities of your embedding model, but you embed them in a space such that you can do a search over them. And if you do cosine similarity, right, for two different sets of paragraphs from two different documents that are really semantically similar, you're gonna get similar results for those in terms of a similarity score. And then you can store those. You don't have to do the step, but you can, if it works for scaling it up, you can store them in an embedding database. You can do that in memory as well. And so a user comes along and he says, okay, I've got this query. What is the rate per engine flight hour for a given contract? Right? Some of these contracts we charge per engine flight hour. It's kind of a new model that we charge customers, and then we essentially foot the bill for the downtime that the engine is not flying in the air. So, and it works out for us, it works out for our customers. So what if I want to know, and these rates, of course, they're not the same, because users, I say users, airlines don't fly their engines. Some of them are in a lot harsher environments, some of them are short hoppers, some of them are long haul, right? So this number varies a lot. But I want to know what the rate per engine flight hour is for a given contract. So you take that, you run it through your embedding model. This embedding model doesn't have to be the same. I depicted them as the same, and I think generally speaking, where retrieval augmented generation is right now, most of the times they're the same. But you embed that query, and then you compare it to your embedding database to say, okay, what are my most similar chunks of text from the documents or the set of documents that I'm looking over? So you can set this. I have K there, but that can be any number. Of course, it should be reasonable and probably tailored to the use case as well. And I'll talk more about that. And then you decode those chunks from that I return from the embedding database, and you actually prepend that to the query's context. So then you kind of have this structured prompt which says, okay, I've got some text excerpts. You kind of give it some context here, and then you literally say, okay, for these, and in this case K was 3, but I've got these paragraphs of context, and then at the end it's your question. And you specifically instruct the model, say, if you don't have the answer, just say I don't know. And that's essentially how retrieval augmented generation works. You pass that as your constructed prompt, your engineered prompt, through your pre-trained LLM model, and then you get a response. And we've seen good results from this so far. But as I say that, there are pitfalls and hurdles that this introduces to. It's not free, right? So one of them is text quality. And so I kind of group these into 3 different categories. The first one is text quality with your documents on the front end of this. So if you watch any YouTube videos, on retrieval augmented generation, it goes quite nicely, right? They have their nice document, and they say, okay, there's just these 3 lines, right? That's beautiful. It's also very tempting to just kind of do that. But what if you are an actual business that maybe they actually use a scanner to scan some documents in, and they're not perfect quality, right? You've got that the YouTubers, they don't show that kind of stuff. And I found that out pretty quickly because I tried this at first, and I said, I'm not getting the answers I expect. And so what I ended up finding was, well, shoot, the text is all out of order. So that was the first thing, non-standard formatting. So this is an example PDF, not from one of our contracts, but something that I actually did where you can see it's a 2-column page. And if you just use the default, if you use that code up top, it's actually going to start from the very top of the page and just work down. And then for some reason it kind of parses on the right first, but then it goes back up and to the left. And it's not intuitive. And then of course you've got stuff like chapter headers at the start of every page. You've got page numbers in there, which maybe you don't want that breaking up the flow of the text that you extract. So another example, and then, by the way, this is kind of my horror story slide. So yeah, non-standard formatting. So this is an example where this is a literal example that we have where the pages are all just tilted. So if you read, even if I fix the sorting issue from the first one, and I just go top down, left to right, I'm going to start just kind of like either not getting the text right, or it's going to just extract it in terrible order. And then poorly formatted tables. Tables are something of a challenge to begin with, but then you have this where, okay, so the idea with retrieval augmented generation is if I've got a table, let me get into a format that's like a pandas data frame, and then I essentially call like .to CSV on it, but then I just kind of put that as text. That's my own document there. So, but how can I even create a pandas data frame? For one thing, it's like, why is that line right there? Like, why did they decide to do that right at 2Q 2020? Like, should all this be in one cell, in a single cell? I mean, so even if I had a table reader that could read different cells, it doesn't necessarily make sense why these things are split up like that. So yeah, I kind of have developed a disdain for Excel users who don't think about stuff like this from working on these things like this. So, the other thing about this table was, well, it's actually split onto another page, and they literally haven't included to indicate that it was another page. They just took off that top line. So this failed my test when I was trying to detect like the top line of a table, right? And well, it's just not there. So you kind of dig in and say, well, please don't do this. If any of you guys out there put text for tables in PDFs, don't do this. And of course, there's like no dividing lines in this one at all. So it's kind of, it's really challenging to work with this. This is another table that was literally taken from one of our contracts, but I've changed the numbers and generalized it. This is the exact format coloring. You can see like there's merge cells going on here. Like I don't know why engine type is over here. That's not a rate. It's the type of engine. So, and the engine type's not even on there. So kind of what's going on, like how do you actually convert this to, in a standard way to like a pandas data frame, which then you can, because really what's going on here is merge cells, there's like a hierarchical index going on, right? So it's a non-trivial problem that does become pretty difficult to solve, and they don't show you this stuff on YouTube. So that brings me to pitfall number 2, which is the retriever model itself. So I mentioned we introduced this model and it's a source of variability. So one thing that happens is, well, you can have an inefficient, or what I would maybe describe as a wasted retriever. And so here's your user query. What is the count of engines across all Southwest contracts? And you can ask that, but if you're searching your vector database for all contracts, why not just filter first to the Southwest ones, right? Can you do a better job up front of extracting metadata so that, okay, I know that these are like my 5 Southwest contracts, so I'm only going to search over these, versus searching for over all contracts and then hoping that the model just picks out Southwest. Because what likely will happen in this case is you'll get counts of engines from all contracts. Maybe some paragraphs that mention Southwest and some, but don't have anything about, about the number of engines. And when you pass that to an LLM, you're at risk of basically the LLM saying, okay, in this portion of the context, I see some engine counts, and in this portion I see Southwest, so I'm going to marry those, but maybe they came from 2 totally different contracts. And so there is a real risk there. There's a couple ways you can solve this. One is, maybe by more explicitly, maybe either regular expression or forcing the user to kind of pick first an airline that they ask a question over. That's one thing that I've done. There's another way is you can actually use your LLM to ask to basically query the query. To basically say, okay, let me try to generate a filter from this query, and then use that to then programmatically filter, and then get the right contracts in your vector database filtered, and then you get much better chance to get the right answer. So as I mentioned earlier, and I use the same table, retrieving tabular data. What if my user asks how many engines were delivered in to be delivered in 2019? Well, this actually is an aggregation task of a table, right? So this is another problem which, maybe you think about, there are specific models that do table aggregations, that kind of thing. Maybe, you have something in your workflow that, kind of routes them to this other model if they need to do some kind of aggregation. Maybe it's a simple check. Is your question an aggregation? Maybe you use an LLM to decide whether their question is an aggregation. I don't know, but this is not a trivial challenge. And then some of the more straightforward parameters or hyperparameters about this that can be pitfalls. Your chunk size. So for a given document, the chunk size is that like basically the number of tokens in the text that you include. And maybe this needs to be, for certain use cases, this should be smaller. Maybe for certain use cases it can be bigger. And then also the chunk overlap. I initially didn't have any chunk overlap when I put this together for this contracts use case. And then I found, well, one of the questions, it was just unfortunate that where the piece of information I needed was in one, but the context for that information was in another. And it didn't, the two, when you kind of combine them or take them separately like that, didn't meet both of them didn't meet the criteria for being included in the, in the semantic search as being returned. So one of them did, but the model responded, I don't know, because it didn't have that other piece of information. So another thing, like with the retriever specifically, how many number of documents, I mentioned K earlier, how many documents do you want returned as part of this? And this, once again, is probably specific to your use case. And also to the size of the model you have. What's the context length of your model that you're working with? How many can you really stuff, with good performance into your LLM model? And then maybe you need a retriever that should be actually specifically trained. So maybe you're not talking about fine-tuning the large language model, but you're talking about fine-tuning the retriever model, where you say, okay, all of my, half of my results, they all have roughly the same to 3 decimal places similarity score, right? So you can kind of look at those metrics and say, do I need to be, differentiating somehow? And maybe that's just a new model or a specific model that's adapted to your domain for the retriever itself. And then query quality. So I have two user queries here. What is the contract price? What's the problem with that? It's too general, right? There's these contracts. I'm asking you guys like you guys have read our contracts, but all right, that's too general. There's multiple different prices quoting, whether it's services, shop visits, all sorts of things, flight hours. And but you could have a user that, maybe he doesn't care about that. He's not, but he's using your tool and he says, what's the contract price? And he doesn't get good results, or maybe he gets the wrong results. That's the other thing that keeps me up at night about retrieval augmented generation is getting the wrong results returned and then having your LLM just, hey, it's got its results in front of it, so it does a good job. It thinks it's doing a good job. The other thing, we have life limited parts, but this is just a simple misspelling. It should be an LLP parts. And so this is kind of alluding to the anecdote I had earlier about executive, the head of our organization that I showed this to, and he had a misspelling. So, but those are just real situations that you're going to have to deal with the results that come from this. Okay, and so my final pitfall is the large language model itself. I will say that I think if you do really well on the first two pitfalls, this is a lot lower risk. And that's why this model is kind of been the go-to. I say go-to like we've been doing this for years now, but the go-to for the past 5 months, I guess. But for a lot of business applications, retrieval augmented generation is the way to go, because if you can reliably do those first two steps, then using the LLM now, use something like Llama 2, you're going to get pretty good results. But it does have some pitfalls. Context length is one of those. Maybe the model you're using doesn't have a very long context length, but you've got large document chunks and your K is 20, I don't know, but you return a lot of context and you don't fit it in the length. So that's something to consider. How to parse the output in a usable way if you need to. So maybe I'm building this contract database, but gosh, my LLM keeps telling me hey, I think I found this information. I've still got to search through its result to get the right information from that. So unless you're just having a person just interact with it, maybe that's not an issue. But I think there still is this case of how do you parse that output in a usable way? Because you can, let me take a step back. You can tell it just give me a number. Please just give me a number. But sometimes there's still some other information in that, and you just can't drop that response into pass it on to your database or wherever you're storing it. And then validation, and how do you quantify accuracy? What's your evaluation metric? Do you need a human in the loop? I hope the answer is likely yes. If there's any kind of risk involved in using these systems. And I think with all of our business applications, there's some element of risk. Unless you don't care if the wrong answer is given, then maybe there's no human in the loop needed. But at this point, I think, and that becomes a scaling challenge sometimes, because I can ask a lot of questions to a lot of contracts, but unless I have a subject matter expert there with me, helping me, figure out are these right or not, and then what happens when I deploy it? How many do we do a sample of these that we kind of someone every once a month goes and evaluates, someone once a day. And these are tough challenges that I think you have to think through, especially hey, maybe there's a new open source model that's on the market, it's at the top of the leaderboard. How do I evaluate that? And then there's, of course, LLMs by their nature are stochastic, right? They're probabilistic. And, there's certain things you can do, like the temperature, they call it the temperature setting of your LLM, where, if you set it to 0, it should always give you the same output. But, if you don't have that at 0, then, or maybe your retriever results change slightly. Maybe someone adds something, maybe your retriever model is kind of a part of the problem, but because of that, your LLM is getting different results for a very similar query, and it's giving a totally different answer. And then, as I mentioned earlier, how do you evaluate this for new models as well? We've been doing some prototyping, and as part of this, and so I think these are just really some suggestions, but I think it's pick a framework quickly for deploying, and that should be a prototype. But Streamlit and Grad.io are both good ones. Of course, as I mentioned, periodically evaluate new models that come out, and then ideally develop a unit test and validation framework so that you don't have to keep reinventing that wheel at the same time. The other thing I'll say about prototyping is that one thing I found as soon as I kind of nailed my version 1 of this retrieval augmented generation workflow, I coded up a Streamlit app the next afternoon, because I wanted to get this in front. I think all too often when you're doing these kind of things, it's tempting to say, well, I've got my Jupyter notebook, I can kind of do a screen share or copy the results into a PowerPoint. No, get it into a Streamlit app that someone can access, or Grad.io app that someone can access, and then put it in front of them, let them play with it and tell you some of the issues. Because they'll get to see the work that you're doing, some of the challenges that you have, and they'll have a better appreciation for it. And then for deployment, this kind of goes without saying, but I did mention it earlier, but consideration of costs. Whether you're using cloud infrastructure, or if you're maybe purchasing the solution from OpenAI, how does that scale up? How does it scale up? And how do you quantify the ROI for your project? And then one of them, the last one at the end here, I like this idea because I'm using it for our contract modeling process. We have a standard format where we say every season we go evaluate a set of contracts, right? And they're collecting these data points. So I'm going to run this in shadow mode, and I'm going to basically say, okay, you guys are getting the answers. I'm going to use that as labeled data and see, can I get the same data? Can I extract the same data, get the same answers? And then I've also can just ask them, how much time did you take to do all of this, right? So run in shadow mode if at all possible. Okay, so this is my final slide, some key takeaways from our journey. I think it's important, forge the use case early. and don't be afraid to lean towards smaller scope proof of concepts, right? At the beginning of this, I thought I was gonna make this like, I don't know what I thought I was gonna make, but it wasn't gonna work. And you know, it was more like an aerospace general model. But I think it's important to just say, let me focus on something, because that's gonna help you really ask the right questions and then deliver the best results that you can for your business. And this goes without saying too, but don't try to make a general model. Utilize the retrieval augmented generation workflow if that makes sense. And then spend time on extracting good data, because it will pay off in your retriever filtering. So it's a painful task, and usually it's hard to explain that, you know, and say, hey, I need to spend time on this, but it's gonna pay off so much more if you do that rather than, you know, following the YouTube guys that you know, just have the 3 lines of code. And then periodically check up on the alternative routes. You know, OpenAI, you know, they've offered already. Microsoft is offering services, right? Anthropic is another one. If you can use this and get access to it, check up on those alternative routes, because that will keep you honest in how you report, you know, whether or not this is, you know, a justified investment for your business to do it one way or the other. And don't be afraid to pivot. You know, it's kind of crazy, but we are here, like, you know, we've been doing this ourselves for the past, you know, 6 months or so, 6-7 months. And I think it's important, just this space is expanding so much. You know, if you ask me to do this presentation in a year from now, it's gonna look a lot different. And I think it's a good thing. It's an exciting thing, because things are moving so quickly. But don't be afraid to try to keep looking at what's the latest and greatest and understand if it makes sense for you. And that's it.
Time for questions. Right there in the back.
Thank you for sharing the knowledge. Question about the contract one. It's a good use case, but the challenge I see is that as contract change over time, addendum after addendum, how do you handle that? And how do you know that is the right contract?
Yeah, that's actually a great question, because it's something we're dealing with. Yeah, each of these contracts has multiple amendments, and it's something we're just trying to figure out how to handle, actually. I mean, one thought I have is, okay, first filter to the contract with its amendments, and then can you basically construct, like take the amendment and add that context that this changes something from the original contract, so that if your LLM, ideally you want your LLM to see the whole story, right? So if your LLM is getting stuff from an outdated version of the contract, but it's also getting stuff from the amendment that is prepended with that right context, that hey, this changed from the original contract, then you can kind of like, you know, more or less find a way to feed the whole story to the LLM. But that is something that we have to evaluate how it performs.
And how do you handle those complicated legal language that sounds one thing might mean another thing?
That's a good question. I wouldn't say that we have actually faced that issue yet. With the kind of terms that we're pulling out specifically for our use case for this modeling process, they are they're more of like numerical values. In some cases they're like schedules, but yeah, we're not getting into like kind of wishy-washy language at this point. But our legal team does want to also talk to us about using this too, so we have to update that answer.
Thank you.
Yeah, sir.
Curious, how did you deal with or treat with tabulated data?
The tabular data is still a challenge, but you know, I won't say it's perfect, but for well-structured tables, my goal is, can I get the title of the table first? You know, usually that's like the line above, but it's you know, more of like a rule-based or computer vision type of solution where I'm saying, okay, let me first define the table, and then can I, you know, find the data that's in this particular cell. For the merge cells, I still don't have a perfect response for that right now, but I think that if you get it in a better format, then it's still, your model still will have a better chance of getting it right. But you know, once again, like I wish I could. Some of these make me wish I could go back and say, don't use these kinds of tables for contracts, right? Can I edit the template that you guys are using to build these? Because yeah, it's the tabular data. I have tried a Tapas model. There's this Google came out with this Tapas model, table answering model, does a really good job, but the problem with that is it gives you an answer for it. You could say, where's my cat this afternoon, and give it that table in the contract, and it'll give you an answer from that table. So it's, there's definitely trade-offs there that you kind of have to, think about for your use cases.
Technical documents are full of pictures, images, plots. Tell me about that.
Well, I mean, so for our contracts use case, it's not as big of an issue other than the tables as we talked about. But for images, when we get a use case for that, I think we're going to be looking. I think that's the next thing on the horizon, right? Most of you guys probably heard that OpenAI recently released, capabilities for ChatGPT to handle images. I think that's going to be, they will be open source models too. That's my thinking, is that someone's going to come out with an open source model that handles images too. We also do something similar for retrieval augmented generation in that case as well. Because right now, I'm really not trying to touch the images. But they also don't offer, for this use case, they don't offer that much information.
So especially since you had the hardware in-house, there was an awful lot of hats that I'm seeing somebody has to wear. Were you wearing all those hats, or was there a large team and different people cleansing data, different people doing
I'm wearing a
all
lot of the hats right now.
Okay.
But our team is pretty lean, I will say. But yeah, I think that speaks to the nature of how to scale this up, right? And if someone wants to deploy this use case, they say, I love your retrieval augmented generation workflow, but I want to do it towards design practices, that we have in our engineering organization, then, that's where you first say, okay, does the bulk of my work lie? And I could say right now, it's more on the data cleaning. And so I think that's where we can leverage what we built, but then scale up in that area. Scale up, I really need a data cleaning team to help us to be able to push this kind of application more broadly in the organization.
So the development of this project doesn't seem like so straightforward. There's still a lot of exploratory work to be done. And I'm curious what sort of advice you would give to someone from like the project planning perspective and like building that roadmap, building those timelines, because it seems just a little bit more open than maybe like a lot of the other types of work data scientists do.
Yeah, this is the kind of question that I hate. It's a tough question,
Yeah.
but it's the right question too. I mean, my way of dealing with this is basically to kind of work in a way that says, okay, I know what I can do probably in the next 2 weeks to a month, right? As things don't change drastically. So I'm kind of coming at this from the other side. Well, I can tell you what I can give you. I'm getting a little bit better about making estimates. Now that these frameworks are starting to develop, like the RAG workflow, but a lot of it is really, as I mentioned in the last answer, the data cleaning aspect is a big thing. So I will typically give caveats, say, okay, if I can get all of this data and it's in this format, but if not, I kind of need the project planner to have some flexibility and just work with me in terms of, but ask the right questions, right? Because I will list my assumptions, and then I can kind of start to bound my problem now with those assumptions, like, okay, if the data is really dirty, then I can add another month, based on going through this. So it's tough because you have to have some experience going through it, and I can tell you the people that would be tracking me on this probably wouldn't be very happy with me.
What's low TRL, right?
Yeah.
It's low technical maturity.
Yeah.
I think that's the big key right now. We're still in a low technical maturity phase. As we get better, the technical maturity will go up, and we'll be able to zero in on what the improvement places are.
Yeah, Ryan's my boss, so he's I can quote that from my performance review. We have it on video.
So my question is around the decision between in-house computing power rather than going to cloud computing. Like, was there challenges in the bureaucracy of saying, hey, let's spend our money on cloud computing versus in-house, because it's there's less redundancy in-house than there is in cloud computing?
There wasn't, there is. So I'll say there is, a conflict. I mean, it's difficult. So even at a company our size, spending this spending this kind of money, and I think part of the issue is there's not an appreciation. Because people don't have an appreciation for the memory requirements, no one's going through the we use AWS, no one's going through their pricing of instances and saying, okay, like I had to explain to them, no, it's not the T3 like medium only CPU only instance, it's this one. They're like, that's gonna be $10,000 a month. And I'm like, okay, well, all right, I'm not training the model that whole time, so it's not gonna be running 24/7, so can we stop? But to directly answer your question, yeah, it's difficult to spin some of this stuff up. I think that it really depends like on the use case in terms of how many people need to use it. Because if you're gonna train it, if you're gonna train the model, if you're just using it for inference like retrieval augmented generation, and you really don't need to train it end to end, then I think you could still do it locally. And also couple that with the fact that maybe I can kind of bound this to a certain number of users, right? And then maybe you prove it out with them. So this is kind of my actual philosophy here is let me prove it out locally, let people use it. They say, yeah, we need this. Okay, now I have some ammunition that I can go and say, we need to spin up some cloud instances. These people like this, it's making, if I can get data on how much more efficient it makes them, like that's fantastic and that will help me. But yeah, kind of like start small and use that as a proving ground to say, yeah, this is where we need, and you'll get the help that you need when the right people, feel the value of your effort.
Last question? Let's thank him again.